Hello everyone, welcome to Akar Maths classes, and a series of sessions, as you know, is going on for polynomials. So we are going to start here with factor theorem. Okay. Now what is factor theorem? See, when we talk about a factor theorem, then for any polynomial px, say you are having any polynomial, okay, for any polynomial, okay, if you have any polynomial, say px, and its degree, suppose any polynomial px with degree, you can say that with degree n greater than or equal to 1, there exists a real number. Okay, there exists this is the symbol of there exist. Okay, this is a symbol of there exist. Okay, we write this, when we write like this, it means it does mean what? It means that there exists. Okay, so there exists a real number, okay, a, right, such that, now it has two conditions. What? That such that x minus a is factor of x minus a is a factor of px. Okay, when it is factor of px, if pa is 0. So this is the first condition. For any polynomial px with degree n greater than or equal to 1, there must be existing a real number a, such that the first condition is what? That x minus a, this a, real number, x minus a is a factor of px. It means that this will become factor of polynomial if pa becomes equal to 0. Okay, and second part is what? Second part is that pa equals to 0 if x minus a is a factor of px. Just the opposite of this. Understood what it is saying? That if any polynomial is there with you px, and if the polynomial has the degree n which is greater than or equal to 1, any degree which is greater than or equal to 1, there must be a number a, there must be a real number a, such that x minus a is a factor of px, such that x minus a will be a factor of px if pa becomes equal to 0. This is the first condition. And second condition is what? If you are having pa equal to 0, in such case x minus a will be factor of px. Okay, so these two conditions are to be satisfied if you have to find factor theorem. So what factor theorem states? I think you have understood now. It is very much clear here that for any polynomial px with any degree greater than or equal to 1, there exists any real number a such that x minus a is going to be a factor of px if, what condition is there? If pa becomes equal to 0. If pa is equal to 0, in such case x minus a is a factor. This is the second one. What? That if pa is equal to 0, then x minus a is ultimately a factor of px. ठीक है, दोनों केसेस अगर हैं, या तो ये केस हो अगर x माइनस ए फैक्टर है px का, इसका मतलब pa शुड बी इक्वल टू 0. अगर x माइनस ए दिया हुआ है कि ये फैक्टर है px का, किसी पॉलिनोमियल px का जिसकी डिग्री ग्रेटर देन 1 हो या इक्वल टू 1 हो, तो उस केस में pa ज़रूर इक्वल होगा 0 के. ठीक है, और दूसरा कंडीशन क्या है कि अगर pa 0 है इक्वल के, इसका मतलब है सीधा सा कि x माइनस ए फैक्टर होगा px का. Understood? So this is only our factor theorem. Let's try to understand why this factor theorem is required. It is required for the factorization. Okay, when we want to factorize the things, we can apply this factor theorem. But before that, let's try to prove it. Okay, this one, let's try to prove. Okay, prove. See, by remainder theorem, what do we have with us? By remainder theorem, by remainder theorem, what it states that by remainder theorem we have Px is equal to x minus a into qx, where qx is the quotient, and plus pa. Actually we have this as a remainder theorem with us. Okay, where a is what? A is any real number and x minus a is a linear expression which divides this px. Okay, such that there exists a pa. Okay, which is the remainder. Okay, which is remainder of px. Now this is the remainder theorem. If this is the remainder theorem, then if, let's see the first part. If pa is equal to 0, okay, let's see first part. If pa is equal to 0, then what will happen? Then px will be equal to what? It will be equal to x minus a into qx. Okay, so it shows what? If this pa becomes equal to 0, in that case px will be equal to what? X minus a into qx by this theorem. Okay, because we are keeping this as 0, you can write here 0, no problem. So what you are getting ultimately, you are getting here px is equal to x minus a into qx. What it shows? That x minus a is factor of px, है ना? px का x minus a क्या बन जाता है? Factor. Even qx also becomes a factor here. These two are giving you a multiple that is equal to px. Px is multiple of these two factors. We are having here two factors of px, x minus a and qx. So qx is definitely a factor because it is, you are getting this after the division, and this is the divisor. So this is ultimately a factor of px. When it is a factor of px? When pa is 0. Okay, when pa is 0. Now second thing to remove is what? If x minus a is a factor of px. Sorry. Okay, if x minus a is a factor of px, then what will happen? Then px will be equal to what? X minus a into gx. So in this case what will happen? Pa will be what? In this case Pa will be equal to what? A minus a, right, into Ga, which will give you what? 0, isn't it? So what it proves? That Pa is equal to 0. Is it? Is it or not? What? If x minus a is factor of px, in such case you are not going to get any pa here. Okay, now if you are not given with any pa here, you are just, it is said here that x minus a in case is a factor of px, in that case px will be equal to what? X minus a into gx, right? And then in that case, if you just check out with this, x minus a is equal to 0, so x equal to 0, right? So if you put the value here, you will see that PA is equal to x is equal to a. So if you put the value of x from here, you will get here PA. If you go for finding out PA here, you will see that a minus a into GA, a minus a will give you 0, 0 into GA is equal to 0. So PA becomes equal to 0. And it proves that if x minus a is factor, then PA will be 0. Okay, so both the things, in fact this was the first condition and this was the second, so both the conditions are proved here. Okay, so this is your factor theorem, and we will start with factorization in the next coming sessions, and we'll try to do some of the questions on factor theorem also. Okay, so we'll be coming with, before starting with factorization, we will be coming with some questions related to factor theorem in coming sessions. Okay, So or you can say in next session only we'll be starting with some of the questions which we are going to do, because we have done some practice questions on remainder theorem also. So we'll try to do some questions related to factor theorem also, and then we are going to start some of the questions, or you can say we'll start with factorization, the basics. From the basics we'll start the factorization. Again the basic series will start for factorization. Okay, so till then, take care, keep watching, and do subscribe the channel if you feel that you are gaining something from the from these videos. And if you like, you just switch on the like button as well. Thank you.